Yep. Okay. So we're Team Aglet. We did the machine energy monitoring, and our product is named Guava Proof due to its color and possible implications that we could use in industry. So go to the next slide, please. Okay. So it's a plug-and-play solution, so it's completely off the shelf. It's mainly designed for industrial activities, so you're looking at full main systems connected to the grid, and it's made to be a sort of in between the power socket and the plug of any industrial equipment. So it means that it's very easy to implement to a system, and it works for almost all industry applications. And it's called the color of it.
Can we have the next slide, please?
Next slide. Right, so this is how it looks. It could be either 3D printed or, best case scenario, injection molded, which would bring down the costs. And one end plugs directly to the machine, the other end goes to the grid. It's really simple to install. You just plug in and it goes. And in the middle, you can see we have 3 current transformers attached to each of the phases. And of course, the resemblance to a guava. Next slide. And inside, it houses all the electronics, which Mukesh will talk about.
Yep, so the electronics, basically the 3 phases go in, get reduced down using some potential dividers and measured by this ADC here. The results of the current transformers are also measured by the ADC. And then all this information is sent to a Raspberry Pi, which, as you can see, lives underneath through some octave couplers for isolation between high voltage and the low voltage side. And so using software, you can calculate voltages and currents and work out whatever power you need or power factor or a whole bunch of other interesting data about your machine. No, next slide, please. Cool. Yep, so overall, the system would be, the electronics specifically is about 50 quid, with the sensors and some of the other casings bringing the total up to about 80 to 100 pounds. And so this is plug and play. No configuration is required for each machine. All open source and potentially could be 3D printed. And no modification to an existing system is needed. It just plugs in line to the power. Next slide, please.
It seems like we're missing a slide. Could you please go to our Teams channel and open up the link that we've sent to the live dashboard? Yes, if you could click on that last link. So we have 2 sensors connected. They're each on independent systems. The graph should hopefully load up any time now. But if I go and turn off one of the sensors, as soon as the graph shows up, you'll see an update live.
Yeah, so in case you've missed that, so this is reading off 2 Raspberry Pis that have some current sensors measuring, and one of the fans, the loads have just been turned off. So
yeah, I think part of the issue might be that this is being opened on Edge. On Internet Explorer, which is going to have a lot of issues. It's possible to open it on Chrome or on Edge or on any other browser. That would probably be good. But when it's on a slightly more modern browser, there is a graph that shows data that's being updated live. Internet Explorer just happens to be one of those browsers that's just incredibly difficult to support nowadays.
Yes, I guess it's a good time to talk about the benefits to SMEs. So the main thing is that it gives you a lot of information that you wouldn't have usually. So one of the main things of our program is that it's able to be configured to send alerts. So say, for example, there's an abnormally high current, it could send an alert to an operator saying that there is possibly a fault in this machine. So you can preemptively determine if the machine's going to fail. And obviously, knowing that, you'll be able to reduce the amount of downtime or completely prevent any downtime that would have occurred as a result. And also on the flip side, you can set alerts for when the machine is drawing low power, which implies that it's being idle. So from that, you can tell where bottlenecks are in the factory, where machines aren't being utilized to their fullest, and that means that you can have a much finer scale of control over the factory as a whole and see where the drains on your resources are coming from.
We should have also mentioned that when this fault occurs, like when the current all drops down, now that I turn off the fans, we've all gotten text messages letting us know that that happened. So it's easy for operators to quickly know when there's an issue.
Sorry, I was on mute, so I was telling you were running out of time, but I was on mute, so you were not listening. You weren't hearing me. Right. Well, thank you very much for your presentation.
Okay, Ben, I think you've got a question.
Yes, my question is, as it's an inline system, does it have any form of overcurrent protection in it?
Yes.
Can you elaborate a little bit on what that is?
Well, so it can measure and indicate that there is an issue. The primary, because it's using industrial rated equipment, so all the connectors and stuff are rated for 415 volt, 32 amp connections, then presumably whatever it's powered into will be some form of breaker box that would have powered the machine anyway with a overcurrent protection. And so this is not something that our particular system needs to implement. And as it uses the current transformers, there's no risk of, or minimal risk of any overcurrent or that sort of problems occurring in the system affecting our additional boards.
To add on to that, on the software side, if excess current is detected, as in set of going above a certain threshold that has been set for each machine, then that alerts operators just as they would be alerted if current were to drop below a certain point for a certain amount of time.
Okay, Andrew, have you got a question?
Yeah, I think the alerts are really a good idea, and I couldn't hear this. So forgive me. Did you say, or if not, can you tell me in what form will the alerts take? How are you going to alert people?
They're just text messages to your phone number.
Right, thank you. I didn't hear that. Thanks.
Okay. Listen, I think we better finish. We're running a bit over time, so thank you very much and to that team.